just okay. So last time we discussed electric power, but I forgot to uh, discuss the unit of power. So if you have noticed, let me enlarge the screen. Yeah. So, unit power, we have discussed that power is equal to work done, work time, and work done is always in joules per second. So this is one of the unit. Then next is most often we are going to use is the watts, right? So unit of electric power is joules per second, or you can call it a watt. So, for example, I have a circuit like this, and say for example 1 ampere current is flowing through this, and I'm applying 1 volt. So this is the resistance we have. How much power would be consumed by this resistance? And obviously as the current is, voltage is 1 ampere, I can apply Ohm's law, right? Voltage is equal to I into R. I can get the value of R. Voltage is 1 volt, current is 1, so R will be 1. So this is 1 ohm resistance. So now I want to find out how much uh, power it will consume. Obviously, uh, P is equal to V into R. This is one of the formula we have. Then we also have P is equal to I square R. This is one of the formula we have. And also we have P is equal to V square by R. And we have discussed in last lecture. So the voltage is 1, current is 1 ampere, the power is 1 watt. Right? Here current is 1 ampere, resistance is 1, power is 1 watt. Here voltage is 1 volt, resistance is 1 ohm, power is 1. Right? So you can use any of the formula based on the given data. You can find out the watt, that is the power consumed by this resistor. And what exactly happens is there will be a drop across this. And how much would be the drop across this? It consumes power. The drop across this will be 1 volt, right? That means it expands 1 joule of energy per coulomb, right? From going from this point to this point, when current flow from point A to point B, there will be the consumption of energy, right? That is 1 coulomb of charge gives away 1 joule of energy, right? Because like this resistance, it has to overcome, right? And then the battery refresh those charges, again the current keeps continuing flowing through this, right? So basically I wanted to discuss that unit of power is watts, another unit of power is joules per second, right? So and you might be knowing this, when I say 1 kilowatt means 1000 watt, right? When I say 1 megawatt, that means 1 into 10 raised to 6 watt, right? So, or I can write down other way, 1000 kilowatt, right? This is also possible. So that is it for unit of power. Then we'll go for Yes, electrical energy. So total, the definition is the total work done in an electric circuit is called electric energy, and I can write down electrical energy is equal to electrical power into time for which that power is flowing through that given circuit. As long as the the voltage is there, the circuit is giving some output. For example, you can imagine a ceiling fan. When you turn on the switch, it starts rotating. That is your electrical energy get converted into mechanical energy, right? In case of filament lamp, in case of geyser, or any home appliances, when you turn on the switch, uh, the power, uh, when you turn on the switch, that means you have applied the voltage and current start flowing through it, and the power is available across the device, and for a particular amount of time, when the power flow through the given device, it consumes some energy, right? And basically we get this one, right? And you can note down here, this is the electricity bill, right? We are getting, and I'm interested in this quantity, 156 units being consumed, right, in a month. Um, this is just a sample electricity meter, but then this is for AC supply we have got. In our home we use, in our home, this is a domestic electricity bill, domestic, right? That is LT meter, right? This is the LT meter, low tension line, and how much power is connected load is 3 kW. You can notice over here, right? And uh, it is a sanctioned load. The connected load or sanctioned load is same, 3 kW. That means all the appliances which you are using at your home is can be having a power utilization to 3 kW, right? And the unit consumed in a month is 156. So it is essential to know how this energy is being calculated. Uh, Here, for sake of convenience, we have got this electricity bill, because it actually gives you the idea about why the energy is important, because we it generates you need to pay for that, right? So, and please remember, this is uh, the power which we are consuming is AC power, right? And we are right now dealing with the DC. What I'm assuming is here is that this fellow is using only resistive load. For example, he's only using resistive load. So then I can compare AC with the DC, right? Why I'm saying this, we'll get back to this in AC circuit fundamental, right? Right now, I'm assuming this, whoever has got this bill is using only resistive load. And what are the resistive load we have? It's the filament lamp, you can imagine, or incandescent lamp. We call it bulb, right? He is probably using geyser, right? Uh, Maybe he is using iron, right? Ironing the cloth or press, we call it. So, so all this resistive load is being used, and then probably I can compare this with the DC, right? Because in that case, your power will always be V into I. In AC, uh, you must have studied. In AC, the power is given by VI cos phi. What is cos phi right now? We are not interested in this. But for resistive circuit, please remember, for resistive circuit, this will be always 1. So your power comes out VI only. Whether it is AC or DC, if it is a resistive circuit, your power will be given by V into I. And now I can compare 156. right? Now I can compare this bill, which is mm, which is for AC supply, but I'm assuming that this fellow is using a resistive load only, right? So the knowing electrical energy is important because that is how you get your electricity bill. How much consumption is happening? We want to calculate that, right? So how would I calculate? Before that, we need to learn what is electrical energy. So mm, so electrical power, we have discussed in last lecture that it is given by V into I, right? And multiply by T will be what? Will be VIT, right? And uh, it will be measured. It is after all, it is a joules of energy being transferred, right? But we don't use this unit, right? We don't use this unit. The unit of electrical energy is, so this will be, no, this is in watts, right? This is in watts and this is in second. So uh, I can write down for watt, I can write down. So yeah, I'll just because I hope you are writing at your end, this will be quite difficult. Let me write down. So this is your power, right? So we have just discussed what is the unit of power. It is watts, right? Right? It is watts, and time maybe in second, maybe in minute we can take, maybe in hour, right? Maybe in hour we can take this one, right? So in short, it is watts, second, minute, or hour, right? So, and another unit for watt, we just saw that joules per second, right? And this is second. So your energy will be in joules. But your energy meter, through which the energy is, uh, through which the energy meter is on, if you are staying in apartment, uh, there is this uh, uh, in a basement you have uh, the arrangement where you get the electricity supply, and through energy meter you get the supply to your particular home, right? So actually the energy meter gives you uh, the energy in terms of kWh, right? That is kilowatt hour, right? If I am measuring it in seconds, so it would be kilowatt second, right? If I am measuring in kilowatt, uh, uh, in minute, it will be kilowatt minute, right? But generally, this is being used universally. Why? Because this is a board of trade unit. Why? Because we just saw in this case, what do you mean by 156? 156 is 156 kWh, right? And for a month, right? It is for a month. So if I have to calculate, say, if I have to calculate for, if I have to calculate, I'll write down here, 156 is the consumption per month. What is this? 156 kWh, right? This is a total unit. And then say uh, 6 or 7 rupees per kWh is the cost of electricity. Then you can multiply this with this one. There are variable cost and there are constant cost, but then you can multiply this and you get the bill, right? So that is why it is called board of trade unit, right? So what do you mean by 1 kWh is 1000 watt has been 1000 watt has been consumed in 1 hour. But this is the rarest of a scenario. You don't see your power you are getting at your home is only 3 kW. You don't utilize this uh, total power in a one day, right? It is a diversified load. Uh, you, okay, let us do a solve an example and try to understand this. I hope this is clear with you that the energy is electrical power into time and its unit is kWh, right? So I write it over here. Say for example, if I have to find out how much he has consumed in a day, this is for a month. I'll divide it by 30 days, right? So how much that would be? That will be 5.2 kW, right? kWh, right? So he's consuming in a day 5.2 kWh, right? Now, if I have to calculate in a given on a given day per hour how much power he is consuming, so I need to divide this by 24, right? Uh, this is a month, right? This is for a month, right? This is for a month rather. This one is our days. This is for a month, and these are days, right? In a given day, in one day, in one day he consumes this much. So per hour, in a one day, per hour, how much power he is consuming? So that will be 5.2 divided by 24, right? That comes out to 16 WH, right? Right. What is this? This is a power consumed by in an hour, right? In a given hour, he consumes 216 watt, right? In a given hour. Now, what is the supply voltage he is getting? He is getting 230 volt, right? So if I divide it by 116 watt divided by 230 volt is the supply we are getting. How much will be that?
Current.
Divided by 230 will give you 0.9 ampere, right? So when zero point 0.9 ampere current flow, right? When 0.9 ampere current flow through a device which is having a voltage across it is 230 volt, and if it operates for 1 hour, I'll repeat, when zero point 0.9 ampere, approximately 0.9 ampere current flow through a device, let me draw here a simple circuit so that you'll get what I'm trying to explain here is, see, this is 230 volt you are applying, right? And whatever the load is there, load means which consumes electrical energy, which converts electrical energy into uh, mechanical energy or heat energy, right? So in electrical engineering, we call it a load, right? All the whole home appliances are termed as a load, right? So we are getting 230 volt, and if it takes zero point 0.9 ampere current, and this continues for say 1 hour, if current keeps on flowing through this device for 1 hour, how much power it will consume? It will consume 116, 216 watt, right? So, and it is for hour, given hour. So this will be the energy consumption in a given hour, right? And if you multiply by say 24 hour, you will come back to this result back, right? So I hope this finding out electrical energy is simple, but then I compare this with your electricity bill so that you'll get understand the application part of it, because this is important to know that how much bill you are getting and how much power you are consuming, right? So please remember the definition and the unit. That is enough for you to understand this. Then we'll solve one example. This is this. Okay. Now coming back to this, let us take a circuit. This is a battery I'm having. Right? This battery. Then I'll have a switch over here. The resistance, or we can go for bulb. Let us go for bulb. Okay. Okay. So how much is the battery voltage? Is 9 volt. Let us make it. Let us make it. 100 volt, right? Now, so the battery voltage is 100 volt, right? How much is this resistance? How far I can go with this? No. Okay. So use a bit. Okay. 50 ohm is the resistance, right? So when I turn on this, what happens here? Hmm? So conventional current will flow. What is the value of this? Now you can note down this value. How much power this circuit is consuming? Can you find out that? Okay, let us try to find out how much power it consumes. Can anyone answer this? We'll solve the circuit. Okay, now we can solve this. It's a 50 ohm resistance, 100 volt. Let me draw the circuit. We are using Ohm's law. This is 50 ohm. Sorry, 50 ohm. This is 100 volt. How can I find out how much power uh, this circuit consumes? Do I need to find out the current? No, I know this formula, that is V square by R, right? Okay. So this will be 100 square divided by 50, right? So this will be 50. it consumes how much? It consumes 200 watt or 0.2 kilowatt. And if I keep this circuit on for 1 hour, if I keep this circuit on for 1 hour, what will be the, this is the power we have got, right? This is the power we have got. This is the power, right? If it operates for 1 complete hour, so this will be energy, kWh, right? Will be consumed, electrical energy, right? This will be your per hour energy consumption. Now, if zero point 0.2 per hour, then if I do it for a day, I need to multiply by 24. If I have to do it for a month, I need to multiply by 30, right? So then you will get your electricity bill for 1 complete month, right? Obviously, you need to multiply by the per unit cost, right? Uh, now, see if I can play with the circuit. Let us reduce this voltage now. Let us reduce this voltage, say by 50 volt. What will happen? Right? Your voltage has reduced, and when your voltage was say, I forgot to show you that how to measure a current. You can measure a current as well. Let us measure a current for 100 volt first. How much is the current? The current was 2 ampere, right? Obviously, it's a Ohm's law. 100 divided by 50 gives you 2 ampere is the current. Now, when I reduce this voltage to half, now that is what Ohm's law says. When you reduce a voltage by half, what will happen? Look at the current meter. What happens is the current is 1 ampere. Now your energy consumption will also reduce because your voltage has reduced. So what decides the consumption of energy? It is the current, right? And that is why uh, when you use electricity for say resistive load, it takes lot of current, and that is why often you must have observed that your whatever the heating loads are there, they consume lot of energy because it takes huge amount of current to produce heat, because voltage you cannot control. In your home the voltage remain constant, that is 230 volt, right? And it will be constant forever, right? Ma'am, are you able to hear me? Hello? Hello?
Yes, sir. Hello, yes, sir.
Yes, yes. Okay. Because there is some interruption.
Yes.
Okay, so I thought, okay. So basically your home appliances are current driven devices. It depends on how much resistance it has to offer. Now, if I reduce this resistance, say for example, make this resistance say 25. What has happened? See, your current has again 2 ampere. So now it again consumes 2 ampere. So how much will be the energy consumption in this case? Can you find out this? So let us compare this again with the previous example. The resistance has reduced and the voltage has also reduced. What happens? See. So this was the previous example we had. Now I'll use same formula. The voltage is now 50 volt, right? And the resistance is 25 ohm, right? So how much will be that? It will be 100, right? Though the current remains same, but the voltage has reduced, right? And the resistance is reduced. So again, it will be zero point 0.1 kW, right? 0.1 kW is the power consumption for hour. If it happens for hour, it will be 0.1 kWh, right? And for 24 hours and for a month, right? So I hope you have got the electrical energy concept, right? Now let us solve one example so that we will be little familiar with uh, this concept. Let us assume, I'll write down over here, you can also note down. There are six filament lamp, you can assume. 6 filament lamps are there, right? And uh, which are of having the rating 40 watt, right? Hmm? This is a lamp which has its rating. This is called rating of it. When you purchase a lamp, you need to tell him what watt of lamp you want, right? There is this zeros bulb you get. The zero bulb is having the wattage 15, right? We also get 40 watt, 60 watt, 100 watt bulb is also available. So there are 6 lamp in this given numerical, this problem which we want to solve. The data is we have a 6 lamp, each of 40 watt, right? And these lamps are being used, and these all lamps are being used 4 hours per day, right? This is one. Then second, you have another appliances that is tube light, fluorescent tube light, right? Tube light we have, right? Which is of 125 watt, right? And it operates for 2 hours per day. Then you have one more appliances that is a heater, right? Which is having a rating uh, of 1000 watt, or I can write down as 1 kilowatt is the rating of it. So, and it operates for 3 hours per day, right? So, how much energy all these appliances uh, will be consuming in a given day, that we want to calculate, right? We want to calculate how much energy is being used in a day, right? And then probably you'll go for a month later, right? So very simple. There are 6 lamp, right? I'll write the solution over here. Uh, so first we need to find out the uh, energy consumed by lamp. So energy consumed by lamp for 4 hours per day, right? How many bulbs lamps are there? 6 lamps are there. So energy consumed is equal to 6 lamps, each of 40 watt, right? Each of 40 watt. Are you getting? This is the unit. This is the rating of a one lamp. So I need to multiply by all these 6 lamps are operated for 4 hours, right? So they'll be consuming, right, watt. But this is a power consumption, right? This is a power consumption. We want to find out how much energy. This is the power consumption, power, right? How much will be the energy consumption? Energy is equal to power, right? Electric power. Energy is equal to electric power into time, right? So you will get 240 into, for how many hours this will be operating? 4 hours, right? So this will be watt hour. Are you getting the unit? This is the unit of power. This is the energy, watt hour, right? So this is for the lamp, right? This is for lamp. Now I can directly write down for, if you have got this one, first one, I can write down for tube light, right? For tube light, it will be what? It will be only one tube light is there, right? Which is of uh, one, only one tube light is there, right? So it is 125 watt into one tube light into, for how many hours? 2 hours, right? So it will be 250 watt hours, right? So this is the consumption, energy consumption, right? Here, 2 hours. Then third one is heater, right? Only one heater is there. So 1000 into one heater, and it operates for 3 hours, right? So this will be 3000 watt hours, right? Now, so what will be the total energy consumption in a given day? Total energy consumption will be, I need to add all this. So my addition will be, uh, let me write down total energy consumed in a day for this given data is equal to 960. Right? This is for lamp. Then, sorry, this is not for the lamp. This one is for, okay, this was for lamp only. 960 plus 250, yes, 250 is for tube light, plus 3000 is for heater. So if I add this one, 3000 plus, it will be 4210 watt hour, or 4.210 kilowatt hour. if I have to find out, say for 30 days for a month, approximately, I'm considering 30 days, I just have to multiply by 30, right? So you will get uh, 1, how much is that? 4210 multiplied by 30 days, that will be 126.300 kWh, right? And multiply by per unit cost, you will get the total cost of your electricity, right? So I hope this example will clear what is power is, the rating of equipment, then how to calculate the energy consumed by the appliances for a day or for a given hour or for a 30 days, right? So this will clear your doubt. Now next we'll go for DC circuit, right? Now comes the DC circuit part. So we have done with all the fundamental, we know how to now calculate all the parameters given circuit. So now we are ready to go for DC circuit. Now we have started with our actual syllabus, unit 1 DC circuit. So what do you mean by circuit? The other day I given this definition that it is the systematic arrangement of passive and active devices where current is intended. That means it is a arrangement where your battery source has to be there. Then there has to be uh, appliances which will consume this electrical energy, and the current flow through this, right? It is also called as a circuit, but very simple definition I'll write down over here. Please note down the closed path followed by direct current. Pardon me for my handwriting, and it is direct current, the DC current is DC circuit. So what do you mean by this? That in DC circuit, say for example, I am having a circuit like this. There's this voltage source, and this is the load we call it. And this load in DC circuit will always be resistive one. Uh, you won't see the inductance and capacitance effect in DC circuit. You will observe this its effect in AC circuit, right? So here onwards, we are not going to considering the circuit which is we are considering a steady state circuit. We are not considering a transient circuit, right? So we need to uh, be very clear that your load will be always resistive. Whatever the load we are going to use will be resistive. Right? So here, when say for example, I am having a switch at this end, and look at the switch I need to operate in this one. When I turn on this, the current will start flowing, and it follows this closed path, right? This is the conventional current, obviously. We discussed this conventional current. So this conventional current will flow like this. From this end is positive and this end is negative for this load. So the closed path followed by the direct current is called DC circuit, right? Mm, and what we need to have in a DC circuit, we need to have a source, right? And we need to have a load, right? And then this connecting wires need to be there because otherwise current will not flow, right? So that is why if you go back to this animation, when I see, when I turn off the switch, now look at this, the connection here. These are simple things which we need to understand. What if I connect, I'll remove this switch, and I will shift this bulb over here. And what if I with this part, what if I connect this switch after the bulb? What will happen? Will it operate? It will operate fine. Right now, look at this switch. It shows some resistance. If you go down here, that it is a infinite resistance. And if you go by Ohm's law, if you have an infinite resistance, if I use this expression, we know this V is equal to I by R. I can write I is equal to V by R. If this is infinite, what will be the current? It will be zero, right? Though the voltage is there, but as the switch is open, this is called open circuit. Please understand this terminology, right? This terminology will help you in understanding few theorems which we are going to learn, right? So this is an open circuit. Now, initially this switch was before the lamp, right, over here. But I've shifted it. When I shifted it over here, what has happened? Circuit works. When I turn on this lamp, the lamp glows fine. But what if I have to? Why do I need to? Why do I need to? This one is 0. This one another switch. Okay, I'll remove this part. Okay, so this is open. When I turn on, it turns on fine, and it open it. Now look at this. What if you want to replace this lamp? No, accidentally, if you touch this terminal, you receive a shock. Right? Though this lamp is not glowing right now. Look at this. Having switch, see, I don't know whether you are getting this or not. Very difficult for me to explain at this point of time. But then, what I'm trying to explain is when the switch was before lamp, here the circuit was working all right. But what if you want to now replace this lamp with another lamp? Right? Even though this switch is off, you will receive the voltage till this end. And if you accidentally touch this point, you will receive a shock, right? And that's why please remember that this switch has to be always not at this point, it has to be at this point. So I'll reconnect the circuit. It is a simple, small fact which we need to understand. Now it's perfectly all right. Now look at this. When you turn off the switch, you can replace the lamp. You won't receive a shock because this is infinite resistance. Current is not flowing. There is no potential at this point. So now you can replace this lamp. You can replace this lamp and you can put some another device, right? You can put another device, right? It perfectly works. Okay. So this is a DC circuit where this is a closed path followed by current. DC current is called DC circuit, right? In next lecture, we'll try to understand what you mean by uh, series circuit and parallel circuit. By because these are simple concept which will help you to um, solve DC circuit problem which are based on theorem. We'll also try to understand Kirchhoff's laws, which are essential. These laws are essential to solve DC circuit, right? So in next lecture, we go for series and parallel circuit. We'll try to understand what do you mean by series circuit. The other day we had one question. What do you mean by series circuit? Um, okay. Any questions do you have? Do you have any questions? Okay. Any question? I don't know. This question is, ma'am, do you have anything to say?
I have given answer.
Yeah. Go ahead, please. Are you going to share the screen of yours?
Mm, No, sir.
Um, So, anything you want to add to this? What we have discussed? Ahmad Naik is asking something. Heat loss rate what is that? Okay, student, do you have any question? There is a question in question and answer box. Whatever we have learned about non-energy, the definition of energy, we have applied it to a particular case. Mm, do you have any question? We can answer that. Otherwise, we'll end the session here and we'll see you on Monday. Right? Shall we end now? Up till now, we are discussing all the fundamentals of we are which we need to understand before we go for PC circuit. And these fundamentals will help you uh, to solve DC circuit, to understand DC circuit. You can develop your own circuit with a small 1.5 volts batteries, dry cells, we call it. 3-volt cells are available. You can design your own circuit if you wish. Mm, And we'll be making use of this animation to understand all the concept, uh, particularly concerned with the DC circuit. Right? This is a good tool you can use at your hand, and you can come up with your questions if you have any. Uh, we'll end our session now. Thank you for joining, and please take care of yourself. We'll see you on Monday. Goodbye. Thank you.